Alright, so I'm going to do a video, I'm going to do a series of videos on Siemens structured text and just some kind of basic stuff about how to use it and how to program for it. And then we're going to do some factory I/O stuff in structured text. So from my previous videos, I think might look familiar. I've rewritten it, but our standard debounce block here. We're going to take a input, maybe like a sensor along a conveyor, and it needs to be on for a set amount of time to turn on another input, or it needs to be off for a certain amount of time. So the idea is if maybe you have a part moving down a conveyor and it hits a stop and then it bounces off the stop, it's not going to flicker and send like 6 different signals to the PLC firing off different events. It's going to handle just one. So we can watch it run. Let me show how this is passed in. So we have our OB1. This is and then we're calling our FB, which is debounce ladder, and then we're using the instance debounce ladder DB. Here's our call. So if we can right click on this and open and monitor, let's roll down here. So if I write this to true, this is going to take 5 seconds to kick on, and it turns on there. And whenever I turn it off, this will drop out, and this run will kick on for 3 seconds. So, okay. So, let's see what it takes to write that in SCL. So, we're going to take So I already went ahead and copied the interface stuff over. So the first thing we're going to do is we're going to call timer, and we're going to use this instance here in the static area of memory for the FB. We're going to use that on delay timer. So we're going to say ON. So we got on delay timer here. Okay. Now, if I come over here, I can right click and go to show all parameters, or it shows you control shift space. That's what I do all the time. Okay, so now we have all of the stuff that's brought in here to our timer. So we're going to match, and it's just like this over here. So on our input, we're going to put raw input. Time in, we're going to use on delay time. Out, we're going to leave alone. See how we didn't put anything over here? So, but if a person wanted to, they could have it go to an output or to another static variable or a temp or an in-out, I guess. Okay. And then ET, elapsed time, we're not going to do anything with. Now, if I want all that stuff to go away, I hit Control Shift Space, and it makes everything go away. Now if I want it to come back, I can hit Control Shift Space. Say later on I decide, oh, I am going to add something to the output. Okay. Then we're going to do our off delay timer. Let's bring up all our parameters that we're pushing into it. Okay. Now I had a person ask me on the other video where I was getting a variable from, I think. So if you notice, this one is blue, kind of like our interface tag up here, and it says raw input. That means that this variable is local to this function block, and then this one, I have a, I guess I should have named it something a little more original. we have this one. This is a global memory marker variable, but we're not going to use this one because we want to be able to reuse this function over and over and over again, reuse this function block over and over again. So we're going to only use variables that are tied to this function block. So we're going to say raw input, and then our preset time is now going to be off delay time. Come on, computer. And then I'm going to make those extra variables go away. So this is where it gets maybe a little tricky, this last network here, the logic for it. I don't mind the structured text, but this is maybe one place that it doesn't look as pretty as ladder. And there would be different ways to do it, but I'm going to try to make as much of an analog to this over here. So we're going to say debounced input, local variable. We're going to do an assignment. So our colon equal sign says that this equals the RLO, or the result of logic operation, that's over here. So in the same way, this is equal to these two, or this is equal to these three. So we're going to say this equals raw input computers is a tad slow. Raw input and on delay timer dot q. So let's take a second and talk about what these parentheses mean. So these parentheses, it's kind of like math. Everything that's in the parentheses you solve first, and then you look at the result of what is inside these parentheses as a whole. So I want to evaluate these two conditions together, or these three conditions together. So I need to break them into pieces, or else it won't solve correctly. Or the quantity not raw input. So while it's loading, let's take a second and talk about that. So we're saying this needs to be false in order to keep our power moving along the rail here. So this needs to be false to get a RLO of 1. Yeah, it's taken way longer to load than I thought it would. Okay, not raw input and off delay timer dot q. Let's make this go away and give us a little bit more room. And debounced input. Okay. Then at the end we need to put a semicolon for syntax, and that'll tell it that that's the end of that line. So I'm going to put some comments in here. Okay, so now I should be able to download this, and then let's see how it looks like it runs. We don't need that open anymore. So if I change this to true, okay, now this came on. Let me go back to our OB1, I can show you. Debounced input gets shoved into this variable, which we've got as a global memory bit. So it came on. Let's move this over a tad, maybe that'll help us see better. Okay, so whenever we're going online with it, we can see the raw input is true. This is what our RLO and our variables are doing along the way. And yeah, see, we clicked on that, and that gave us each one of the conditions here. It says debounced is true because raw input is true, and on delay timer is true. Okay, so if we write it to false, what do we get? I wasn't paying enough attention. Okay, we write it true, we wait 5 seconds. Okay, we write it false, we wait 3 seconds. Yeah, okay, so functionally they work the same too. Alright, so I guess maybe we'll take a minute and look at some stuff about the program, maybe memory size and that. Program info. So our FBs, the SCL one comes in at 400 bytes less, and they both use the same amount of work memory. So I was doing some digging through TIA openness and the XML files for ladder, and I think the extra memory, the extra load memory comes into there's XML information that's captured for like these wires here in between, and whereas in our structured text program we don't have all that stuff, so I think that's part of it. I'm sure we could add other stuff to push the memory ahead of it, and then I have it pushed into a 1200 right now, so we don't really get, there isn't the most elegant ways to get scan time information about these as far as what runs faster one versus the other, but as we get into the further down into this project, we'll find more stuff out about what works better with structured text and what doesn't. Okay, well, I hope you guys enjoyed this video. The next video will open some factory I/O stuff, and maybe the assembler project, and we'll debounce inputs, and then so we'll make another function block to handle that, and then we will maybe we'll do some stuff with their funky actuators and solving those problems. But thank you for watching. I hope you enjoy the video.